All attendees are in listen-only mode.
Good afternoon. Welcome to today's webinar on non-GUI test automation. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm. We serve clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. RBCS has a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. I'm the author of 14 books on software testing, as well as being the past president of the ISTQB. If you have any questions during the course of the webinar, you may submit them throughout the presentation via your webinar interface, but please note they are answered only at the end. Hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for profit company. If you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. We're happy to provide a quote for any such help you might need. Contact us at info@rbcs-us.com. And on with the show. Okay, well, as the title says, we're going to talk about non-GUI test automation. So in other words, test automation via interfaces other than the graphical user interface. And specifically, we're looking at file, database layer, and services layer, as you'll see. Hence the little visual metaphors there. So, you know, as I've said for years, test automation is great, except when it's not. It's like a lot of things. When it works out, it's really fantastic. But then when it goes wrong, it can go really, really wrong. We've working with clients, we've run into a lot of test automation failures of one kind or another, and some of them have their roots in automation via graphical user interface. Now, I've got nothing against automating at a graphical user interface where that's the right interface to automate at, and where it is done appropriately. But what I do think was a massive wrong turn in our industry was when in the mid to late 1990s, there all of a sudden became this accepted wisdom regarding test automation that if you weren't doing it through the same interface that your user was using, you weren't properly testing. There was something ungenuine about your testing unless you were going through the same interface that your user was using. And since everybody was going through graphical user interfaces at that point in time, the implication of that was you need to test through the graphical user interface. And a lot of that, surprise, surprise, that message was being pushed by vendors who were pushing graphical user interface test automation tools. And, you know, I certainly used some of these tools in the 90s, and there were a lot of problems. Now, you know, we have better tools now, but some of the same problems still exist. And so I think that the test automation pyramid is a really good way of thinking of this, the agile concept that, you know, with your automated tests, you want a whole lot of unit tests automated, you want some integration tests automated, and you just want a few system level tests automated if those tests are going to be automated through the graphical user interface. Now, you might say, how does one do that? Well, you got command lines in some cases. Now you could say, well, I don't have a command line. Well, there are ways to build command lines into applications with a fairly light footprint fashion. I've used a scripting language called TCL to do that before. Sometimes you'll hear it called Tickle. So you can build a command line in. Of course, you probably have API layers available. Not available to everybody maybe, but available at some point in the build and delivery pipeline of your continuous integration system. So you can automate there. Data layers, you know, applications generally do have data layers, and you can automate at data layer, and I'm going to show you an example of that. Um, and also network services or other kinds of service layers can be used to automate. Basically, any place where your application either currently presents interfaces to the big wide world or can be brought to do so can potentially be an automation interface. Um, and what is often true is that those interfaces can be more stable than a graphical user interface. So I want to show you a couple examples, because you may have heard people say this, heard people say what I'm saying before, but then not had them be able to produce any sort of concrete example. So what I want to do is show you a concrete example, one at the data layer, one at the network services layer, and each of those are automated using a flexible and maintainable keyword-driven architecture. So if you've heard, well, yeah, you can automate through other interfaces, but keyword-driven is only for GUI, that's not accurate. Oops. Oh, why did it do that? Okay. Apologies to George Romero. The scene from Dawn of the Dead here, where the dead come in through the elevator as it opens and get ready to eat somebody. Now, that's pretty scary if you find zombie movies scary. And that's certainly, if you've never seen Dawn of the Dead, it is a classic horror movie. It is terrifying. It is also exceptionally gross. So if you watch it and say, "Wow, that was really gross," don't blame me, because it is. But the reason I use this metaphor here is that plenty of my clients have told me stories about test automation that are like these sort of zombie apocalypse horror stories, of just, oh, this endless horribleness that happened. And maybe it's not quite as gross as Dawn of the Dead, but definitely very painful, and something that just went on and on. So some of the things that feature in those sort of test automation zombie apocalypse stories that I've heard include massive amounts of false positives. So like half of the tests fail, and when you dig into it, only 2 or 3% of those are actual defects, regression defects that have been caught by the automation, and the rest is just some sort of weird, whoops, we forgot to set up a precondition, or whoops, the data wasn't arranged properly, or whoops this or whoops that. And then, that's bad enough. You think, okay, well, at least if there's a lot of false positives, there are probably very few false negatives, because the tighter you make the filter, the less stuff leaks out, right? Well, unfortunately, with automation, that's not the case. I mean, certainly with manual testing, what you generally see is that as the false positive rate goes up, the false negative rate goes down, because the message that you're sending to the testers is, if in doubt, just report it. But the thing is that the tools, of course, you can't like send a message to the tools. They're tools. They're idiots. They have no brain, right? They're just programs. Now, at some point, we'll get AIs, and they won't be idiots. They'll actually have smarts, and we'll be able to say, if in doubt, it's a bug, and so forth. But at this point, what you have is a tool that just knows how to check for first pattern matches of various sorts, and if it doesn't find the match, it says that's a fail. But if it finds the match, then it says that's a pass, even if something else is going on the screen that it doesn't look at that ends up being a problem. Now, this isn't exclusively a graphical user interface issue, but it certainly can be exacerbated by the way that graphical user interface automation works, because it often, to avoid getting a high false positive rate, you tell it to ignore certain parts of the screen, which then, if something bad happens on that part of the screen, you don't catch it. Another thing that you'll hear a lot about is the so-called flaky test problem, which is, I run the test and it fails, so then I just go ahead and rerun it in an automated fashion, and it passes, and I rerun it again to see what happened, and it passes, and then I rerun it again, and it fails. So this sort of non-deterministic behavior, sometimes it passes and sometimes it fails. The underlying thing being tested, when tested manually, passes and works just fine, but this makes the cost of running the test very high. And all of these three things, the false positives, false negatives, and flaky tests, lead to a very high cost of executing the test, which of course is completely counterproductive to what you're trying to achieve with automation, right? So the whole point of automation typically is to make the test execution process faster and more efficient in terms of the human resource required to interpret the results, but doesn't always happen. Another problem that I hear about with clients with respect to automation is the difficulty in obtaining reliable and or complete test oracles. Now, the test oracle, remember, is the thing that tells you whether the test has passed or failed. And what can happen is that that it's just very difficult to get that. Like, for example, my gaming clients have real limitations on what they can accomplish with automation, even if they can get past the false positive, false negative, and flaky test problem, just because of the question of, well, what is good supposed to look like? In a computer game, it can be a lot of very subjective things. The testing consists of a lot of validation as opposed to just verification that the system works per the specifications. Now, if you're testing an accounting package or a banking package, that can be somewhat less of an issue. But you still have the first three problems for sure, regardless of the package that you've got. Of course, anytime you test through a graphical user interface, any change to the graphical user interface can potentially break the tests. And all of these things lead to potential disproportionate, not only test execution costs, but also test maintenance costs. Now, when I say disproportionate, what I mean is that a relatively small change to the application under test or system under test, depending on what it is, can result in really significant amount of test maintenance. Usually the symptom of this that I see when I go in and work with clients is that the client automation staff describes for me a situation where they spend most of their time doing maintenance of existing tests and very little time adding new tests. And then the final thing that can come up and be a source of complaint, usually in conjunction with an overall lack of return on investment, is the very high commercial tool licensing costs. Now, as we see open source become more and more important, this becomes less and less of an issue. But it still does come up, and some of my clients, because they feel like they have to have commercial tool support, feel like they have to have a commercial tool, which means they end up having to pay commercial licensing costs, which end up being painful. Okay, so enough zombie apocalypse. So what do we want to try to do? Well, one of the things that we want to try to do to deal with that, to escape the zombie apocalypse, is use a modularized automation approach. And keyword-driven design is kind of the current pinnacle of that. So the keywords, if you're not familiar with this technique, is basically they're like use cases at some level of granularity, whether fine-grained or coarse-grained. You'll see it defined differently, but the keyword defines some sort of business interaction with the system. Place item in shopping cart, remove item from shopping cart, checkout, shopping cart, save shopping cart. Those might be examples of keywords for an e-commerce application. And this allows for a few things. One is that it allows testers who are domain experts, who are business oriented, to write the tests in a sort of pseudo-human language. Now, they do have to be concrete tests. You can't use logical tests like you would with a human being running them, but you can write them in English. So use something like add item to cart, comma, red pencil, or well, comma pencil, comma red, comma 20, where the last is a quantity of 20, right? And those might be, fitting into a dialog box that's going to pop up on the screen, or perhaps going below that into the actual business logic and avoiding a screen altogether. Now, that approach allows the automation piece, the scripting piece that actually interfaces with the the interface of the system under test through which we are testing um, to be done by technical folks, and those scripts can be separated in various ways. If you are doing it through a graphical user interface, for example, you would tend to separate them out screen by screen so that if any given screen changed, you would just change that script. But if you're not going through a screen, if you're going through a some other like a API layer, service layer, data layer, then the script would just talk to that layer. And of course, from the point of view of the tester who's focused just on the business process model or the use case, they don't actually care what the interface is. They just say, okay, well, this is the test I want to run. So what will happen is that the technical testers or SDETs or dev testers, whatever they're called, will create a system that basically can interpret these keyword-driven tests and run them. Now, I say interpret. It is usually if somewhat interpretive or interactive thing. It's just pretty rare. I guess I could say I've never seen it for there to be actually a compiler. But usually there's a front end piece that allows you that helps the testers build their tests, their keyword tests, and context is used to help avoid any situation where the tester selects the wrong thing for a particular field. So in the example that I gave about add item to cart, comma pencil, comma red, comma 20, instead of the tester actually having to enter that manually, the tester would select a keyword from a drop-down list, add item to cart, and it would know, okay, there's three things here. There's the name of the item, there's the color of the item, and there's the quantity. And the name is, off of a particular pull-down list, and the color is then determined by the name of the item that was selected, and then the allowed quantity is also determined by the name of the item selected. So it helps avoid accidentally selecting something wrong. And then when the thing goes to run, the keywords are going to basically be mapped into a certain set of scripts, and that'll interface with the execution virtual machine, which, as I said, is basically interpreting. So it's going to go through and it's going to go, okay, we're going to do the first keyword, run it, log the results, possibly recover from some sort of error if it occurs, but if not, move on to the next keyword. And ideally, there's also another nice little front-end piece built into this, which allows the tester to select test suites or even individual tests within a test suite, and in the absolute best case, to run those in whatever order she or he wants. You don't always see that, but really, really nice ones will allow that. And so there'll be an initial set of keywords that will be automated via the scripting effort, and of course the front end and the logging interpretation, the suite selector, and so forth. Those will all be built, but then you also have to have extensibility to be able to add new keywords and modify existing keywords. And again, this is true regardless of the interface. And these are all things that are going to be true of the two case studies that I'm going to show you. Okay, and so just to sort of put a final cap on this keyword-driven stuff, the test cases are keywords, instructions, as I said, with data. Also expected results. I didn't mention that in the previous example that I was giving because it was just the keywords and the data. But expected results. There can potentially even be decision making built in. The points about the advantages, just to recap, the keywords are defined by the business experts. The technically focused testers are the ones who create the automation. That should say technically focus, not business focus. Sorry about that typo. The tests are maintainable, and the specifications are independent of implementation. In other words, the script that I was just talking about of the e-commerce site, that could either automate through a graphical user interface, but it could also, as I said before, automate through the business logic. So we could rewrite the scripts to direct the inputs directly at the business logic, assuming that we have a proper set of APIs for that, and the keywords and the tests wouldn't necessarily have to change at all. Now, some things that are important here, of course, these scripts won't build themselves and the tests won't build themselves, so that whole process has to be integrated into the lifecycle. There usually is some sort of underlying tool that is either some open source tool that's been obtained, or in the examples that I'm going to show you, something that we actually built ourselves. And that's the thing that actually reads the tests out of the keyword files and runs them. Now, the tests are not magic, regardless of whether you're going through a graphical user interface or some other interface. You're still going to have situations where there is an anomaly that will pop up, a discrepancy between the actual and the expected result, and the tool won't be able to analyze that for you. It's going to have to appeal to a human being to look at that. Now, at some point in the not terribly distant future, we'll have AIs to help us do this, but for right now, we don't. So you do have to expect that the false positive rates will be higher with any form of automation. You have to be realistic about that. All too often, people assume that there isn't going to be any kind of analysis of results required. The odds are that if that's happening, if your effort associated with executing your automated test is very, very low, then either you have an exceptionally low regression rate, well below the usual average of about 7% of defects being regression, or you have a high false negative rate, which of course is not good. Okay. So let's look at a couple of case studies here. So the first system that we're going to look at is one that manages a highly diverse set of systems in a network, in a data center, with various kinds of operating systems and various kinds of networks and so forth. So this is built to allow administration of accounts on different kinds of systems. And there's a central workstation that talks to what are called agents that run on each one of the systems. And that central workstation allows you to do things like add accounts and delete accounts and monitor the servers and so forth. So the way the tool works is we start from the right side to begin with, looking at the part that says system under test at the top. There's the agent, okay? And there's also this interface called IRMA, which I forget what that stands for, but it's part of the system under test. And then there's the enterprise server database. And so the tool that we built is able to talk to the agents either through the IRMA system or through the database. So it's basically, IRMA is kind of a real-time communication. The database is more of I put the data in there and then the agent reads it. So those are providing us a network services layer kind of interface, as well as a data layer interface. And now moving over to the center and the left side of the graph, what we see here is that there is a component, if you will, a module called scr_com.tcl. So that's that TCL or Tickle scripting language, as I was telling you about before, which is what we used to implement this automated testing tool. So the scr_com.tcl, this is the module that's responsible for communicating through the interfaces shown to the agent. Nothing else talks to the system under test. So if the way that we want to talk to the system under test were to change for whatever reason, either we select a new interface or one of the available interfaces changes, the only place that we have to change, the only thing we have to change is that TCL script. We could conceivably have made that TCL, that SCR_COM TCL script talk to a graphical user interface. But we had no need to do that because we were insulated from that, but that's certainly something we could have done. Now, if you look to the immediate left of SCR_COM.TCL, you have SCR_add_user.tcl, SCR_del_user.tcl, and so forth. Basically, every keyword had its own TCL script that knew how to send the right kind of sort of meta commands to the SCR_COM.TCL module, which would then format that up to be specifically what the interfaces of the system under test were expecting. We could always add another keyword by simply packing up another TCL function. Just create one, drop it in there into the test system. And all of that was being executed by this, as you see at the bottom, an extended TCL interpreter. So as long as we followed the rules of the TCL language and wrote those scripts accordingly, we could add them. I'm sure there is some limit, but it would be very, very large, most likely much larger than the number of keywords that we could possibly define. Now, the tester doesn't see any of this. When I say tester, I'm talking about the business-focused tester, as opposed to the SDET/technical tester, who's the one who's building this. What the tester would see originally was the SCR_master.tcl. So they wrote the test cases. So those are the files that say .case, .input, and .expect, which, as you can see from the legend, are the ones that the business-focused testers build. They had to write those originally in a format that could be parsed by the SCR_master.tcl script. And of course, those are the .case files are, of course, the inputs, or excuse me, the cases, the names of the cases, the keywords to be used. And then the .input files are the specific inputs. So the thing like pencil, red, 20, any sort of files that need to be gathered up and so forth, all of that would be made clear in this file, those .input files. And then the .expect files were the expected results, and they were all made unambiguous by the name, which would be like a 3-character identifier followed by a suite number followed by the test case number, if I remember right. But that was all a little bit cumbersome, so we eventually put an intelligent front end over that would manage those .case, .input, and .expect files. And so all the user would actually see is this graphical user interface, ironically enough, that allowed them to create, update, and delete these .case, .input, and .expect files. And they didn't really have to remember the names at that point. It managed everything for them. So when the SCR master script would read those files, and then it would send them to the parser, the SCR_TC_parser script. This separation allowed us to change the way that certain lines would be parsed depending on what the keyword was that we were dealing with. So that actually added additional flexibility rather than having the parser and the master. And then that sort of meta command would get sent out to the appropriate keyword function, which would then further package that up according to what the keyword was supposed to be doing, and then it would send that to the scr_com function, which would then communicate with the interface of the system under test, and then they get their results back, and that would get passed back to the keyword file, which would get, or function, which would pass it back to the master, and then that would get passed to the parser, and the parser would do the comparison, and it would send the results of the comparison down to the logger, and the logger would create the .log file, which was done at the suite level. And then what happened is eventually we put a wrapper around that too. So originally the suite file, like the other three files, the .case, .input, and .expect files, was just an XML file that was edited directly by the tester, or in this case, in the case of the log, read directly by the tester. But what we did eventually was put an interpreter that would sit above the suite logs and interpret them, and actually, highlight with color and so forth. It was pretty nice and pretty simple too, because using XML, one of the nice things we're taking XML and we're taking TCL, which were at that point reasonably mature, and had lots of open source stuff laying around to be used to extend it. So there were a lot of things that we were able to just kind of grab onto and use as building blocks. If I'm remembering right, there may have been some sort of fee that we paid to get the interpreter, the base license or something, but the overall expenses from a tool point of view for this were really, really low. Mostly it was myself and my three colleagues and the time that we spent, building this for our client. That was their major expense. Okay, so that's one. So now let's look at another example. So this is a data analytics, data extract tool that can pull data out of all sorts of different kinds of repositories. So you can see that there's, starting from the left, it can go from talk to System I systems to get DB2 data. And before you laugh, yes, it's still out there. Yes, we worked with a client just last year that runs their whole business off of System I in conjunction with other things. And there's still plenty of mainframes out there, so it could do DB2 and ISAM. And again, before you laugh, there's lots of that out there. In fact, there was a study not too long ago that said that the majority of mission-critical transactions are still implemented in COBOL on mainframes. If you were to just look at all the billions and billions of mission-critical transactions that run every day, point-of-sale systems, inventory queries, and so forth, a majority of that is COBOL and ISAM/DB2 mainframe stuff. So now the systems could also, the system under test could also talk to Unix systems and the various kinds of databases, both common and operating system specific SQL databases available on Unix. For MS Server, it could talk to the MS Microsoft SQL. It could query VMS databases and other kinds of tree structure like B tree and C tree. Again, before you laugh, there's plenty of that out there. And it could also get files off of various network accessible files, so it could do direct file reads as well as going through the servers. Now, what made this particular application particularly nice to automate was that it had a command line interface that allowed access to the data layer, and this command line interface was English-like and non-procedural. So it was something like, if you're familiar with SQL or SQL or structured query language, whatever you want to call it, or squeal, as I've heard some people call it, it's like SQLite. even easier than that. Designed to be something that just about anyone could use. So it's 4GL-ish. And the command line interface is really stable, and it is accessible to various open source scripting languages depending on what operating system the host is running on. So we would be able to write scripts that would basically talk to this command line interface and use that as a way to get at the data layer directly. So the whole thing is scripted. For the most part, we used Unix scripting and looked for open source tools that would allow us to run Unix scripts on various operating systems, which worked on every operating system except for VMS. VMS, we were not able to pull that off, and we actually had to have a separate DCL implementation of the scripts, which was painful. But once we got them shadowed, the maintenance actually wasn't that hard, because what the scripts were doing was the same thing. It's just that the language was different. So if you look at the system under test, we have the data analytics tool. Again, remember there's the command line interface. So that's what we're going to talk to. And it's going to either do a data read via an API or a direct data read out of a file, but we don't care, right? Because the tool itself is insulating us from that. And you might say, well, does it insulate the user from that? Yes, it does. We were actually talking through this command line that was basically talking into the same business logic that the graphical user interface was going to talk into. So what we were doing while we were doing it with a different interface than the user was doing was identical to what the user was going to do. It's kind of like, in a funny way, sort of analogous to what I was describing with the previous tool. Whereas remember I said that at first we were editing the XML files for the case input and expect files directly, or we were having the testers do it, but then we put a front end over that. Well, we're using an XML editor to edit it directly before, and then we built the front end on top of that. Well, in this case, it's kind of similar to just XML editor versus the graphical user interface with a pull down. The graphical user interface with the pull down was just a pretty presentation layer put on top of the same logic that we were accessing through the command line interface. So didn't matter, basically from a point of view of, are we testing the same thing that the user is going to see? Yeah, like 90% of it, with the exception of the presentation layer. So the tool had test cases that were defined, and these were in individual files, and then they were grouped together in test suites. And there was a certain logic to the way that the directory structure was set up, so that you could kind of figure out where the test was and what it ran against. And then there was expected results that were organized by either a common area or by operating system database combination if they were specific. About 90% of the expected results were not specific to a particular operating system database combination, which was nice. It made the test very portable across new supported OS database combinations. So there's a parser at the top end that reads the test cases, and mostly this is a shell script, a Unix shell script. And then there's the data read logic, and that's what talks directly to the data analytics tool, the system under test. And then the results of that get passed to a smart comparator, which knows how to locate the expected results based on the name of the file, the name of the test case, and the name of the operating system database combination we're testing. And then it does the compare log. So the business-oriented testers are working on the blue shaded stuff at the left side, and then in the middle, the scripts, which, as I said, can be OS specific, Unix or VMS, are all those things in the middle there, or if you prefer, on the right side of the test system column. The gray shaded stuff on the to the right of that is the system under test. So this was a little bit less tester friendly than the previous example. We did not have a fancy front end to build, update, delete, maintain the test cases. This was all done via editors, VI for the most part. The expected results would be defined by reference to files, and those would be hard coded file name references, but it wasn't that big of a deal because the file name references corresponded to the test case name, so it was pretty obvious what those would be. And then the location of the expected result again would be it would check to see if there was an OS database specific expected result first, and it would use that if there was. Otherwise, it would just look for the common result. So you could have both common and OS slash database specific results for the same test. The comparator was the only thing that wasn't written in shell scripting language. It was written in C, and this allowed us to carefully deal with some of the things that could otherwise result in false positives. There was some risk of false negatives associated with this, but very minimal, because what we were dealing with was raw query results, basically text, comma-separated text or tab-separated text, with each record being its own line. The only exception to that was when the queries actually resulted in reports that were tended to be printed. Then we had to be kind of careful that we didn't mask out too much, but still we had a very, very low false positive rate. In fact, I struggle to remember any single incident where somebody came back to us from the tech support side, excuse me, complained about a defect that had come up in production, and then it had turned out that we had missed that through one of our tests. In other words, we tested it, the test had actually revealed the anomaly, but the comparator had failed to catch it. So it was good that way. It also allowed for variation in record order, because different databases could sometimes sort in different order. So we needed to be able to accommodate that, and it could. Okay, so as I mentioned at the outset, we have a lot of clients that have told us tales of woe with respect to test automation efforts, and a lot of times that comes with the part that talks about we were trying to test through a graphical user interface. Now, again, I'm not against testing through a graphical user interface when it makes sense, but I really do think that agile test automation pyramid, whether you're doing agile or not, is a really smart best practice to follow. And so try to push your test down into those lower layers. And of course, that also is compatible with the shift left concept that everybody's talking about these days, and that RBCS has been talking about since the mid-1990s. Detect and remove defects as close as possible to the point of introduction. Keyword-driven testing can be used for non-GUI automation. As you've seen, we've got a couple. I showed you a couple examples. There are plenty of other ones out there. So, keep that in mind. What you saw were service layer and data layer examples, but there can be at any other layer. The idea is that you're encapsulating the business logic into these keywords and using that business logic to express tests. And in our experience, working with a number of clients on this can often be done with open source tools, which means, hooray, no big tool budget. So it's not often that you get a chance to use a word like defenestrate in a technical presentation, so I had to jump at it. Defenestrate basically means it's an odd Latin origin word, though I heard some people when I gave this talk in Poland say there was actually Polish origin, but whether it's Polish or Latin or what something else, to defenestrate basically means to throw something out of a window. So what I'm going to suggest is that rather than be so focused on window-based, GUI-based test automation, think about throwing some, if not all, of your automated tests out the window, away from the window, down to a lower level, like unit level and integration level. And I think if you do that, you'll be happy to find that the maintainability significantly improves. Okay, that concludes the presentation. At this point, I will answer questions from the audience, so please submit any questions you have using the GoToWebinar Q&A feature. First, quick word about our services. As I mentioned earlier, we have a team of international consultants that deliver customized training, consulting, and expert services to companies looking to improve their test and quality assurance practices. If you receive valuable information from our free webinars, please help us to continue to provide them by making RBCS your preferred software testing vendor for any and all expert services, consulting, or training. Happy to provide a quote for any such help you might need, so contact us, info@rbcs-us.com. I got a couple email questions to start us off. If graphical user interface or GUI test automation is problematic, why does RBCS offer training on GUI test automation, such as the A4Q Selenium Tester Foundation and the ISTQB Advanced Test Automation Engineering courses? Fair question. So one of the things that sometimes happens is somebody will say, well, you should prefer X to Y. And that gets heard as so-and-so said that X is perfect and Y is evil and, the son or daughter of Satan. You see this happen with Agile, where people will say, prefer working software over extensive documentation, and people walk away from that and say, see, we told you we don't need to document anything. Well, that's not really what the Agile Manifesto says. It just says that, the fact that you wrote a bunch of extensive documentation doesn't actually add a lot of value for the client if it's, those are requirements and design specs, and then the software doesn't end up following, right? So write down what you need to write down, but only to the extent that it's necessary to support the delivery of working software. So same thing here. My point is, automating at the graphical user interface is certainly going to continue to be part of how a lot of test automation gets done. And we're happy to support clients to do that. So we do assessments, for example, and we build automation for clients. And we're, if the graphical user interface is the right interface to go through, then, we're happy to do that. And we think that Selenium is a good tool for doing automation, certain kinds of automation. So we're happy to help clients do that better. And we think that the ISTQB test automation engineering framework gives a good way of thinking about graphical user interface test automation as well as other interface forms of automation. So we're happy to help with that too. All that said, what we would like to see is more clients doing more automation at the at other layers, data layers, network services layers, etc. So it's not that we have some sort of animus here towards graphical user interface test automation. It's just that we've seen it not work out as well as other alternatives, and we like to help our clients be successful because that's what you pay a consulting company to do, help you be successful. And so we're happy to do that. Now I got a question from Errol who asks, what is your opinion on the Tosca tool as an alternative? Now, if I am remembering right, the Tosca tool is one of these model-based functional test automation tools, right, Errol? That's what that does. You build models of the. Errol says yes. So here's my thinking on model-based test automation. Well before the Tosca tool came around, back in the late 2000s, I helped a client build a model-based test automation tool. It started off being kind of a dumb monkey, if you're familiar with that term, a random input tool. But we rapidly discovered that we had available to us a set of diagrams that corresponded to the menu flow, because this was a kind of like imagine a browser-based application or a mobile application where you have this sort of tree structure of screens that you can see, and it's fairly limited as to where you can go. So there's a real clearly definable patterns or paths by which you can traverse the tree. And what we found was that those could be used as a model for how the system could navigate the workflow. And then that was the way the model was built. It was also possible to determine what the expected results were to some extent. And so we did that. So we built, I think we used Perl scripting, and Unix, again, building it on top of Unix. And in the space of about a month, we had this fully functional model-based testing tool, and it worked really well. It did excellent reliability testing because you could just fire it up and let it run forever. And it also did pretty good functional regression testing because it did have false positives and some number of false negatives. It wasn't really very high because the specifications, these models that we were using, had to be very detailed because they were subject to FDA audit, Food and Drug Administration in the United States. So that worked really well. And so, I mean, based on that experience, I know that it is possible. But what I also know from that experience and from what I've heard other clients talk about is, these models don't come for free. And if you have to build them, that requires some skills. And I worry about something that I see a lot. This is nothing to do with this specific tool. This just has to do with something that we see happen with clients, which is that you get people doing automation using tools, and the tool makes it very easy to do certain things, but it is no substitute for test design. And there is a great video that you can find out on YouTube, and it comes from a Disney movie called Fantasia. And the video clip is called The Sorcerer's Apprentice. And the idea here is that the sorcerer goes away and leaves behind his apprentice with orders to clean up the magic lab, or whatever you'd call it. And the apprentice knows just enough to get him into trouble. And I'm not going to spoil it for you. If you haven't seen it, go and take a look at it. It's not long. It's really worth the trip out to YouTube. Plus, while you're there, you can view some recorded RBCS webinars, which will definitely be worth your time. Anyway, after you watch the Sorcerer's Apprentice YouTube video, I think you'll get what I mean about people using tools that have sort of a basic understanding, but not enough sophistication. So, I would say, model-based testing conceptually is fairly sophisticated. It's not just getting a tool and getting some introduction to how the tool works. Probably not enough to make you a full-blown wizard. It probably just makes you the Sorcerer's Apprentice. That said, there is some interesting work being done. Sorry about the background noise there. There is some interesting work being done with model-based testing, and of course also with AIs now. So this is an interesting time to sort of watch that space and see what happens next. Okay, well, very good. Thanks for your participation. Thanks for showing up on what was for some of you all a holiday. Close this session. Remember, we run these free webinar sessions once a month. Next month will be a 2 points of view at 2. We're still figuring out who exactly we want to talk to, but we're gonna come back with something interesting, an interesting set of perspectives. Check out our website, rbcs-us.com, to sign up for free webinars. While you're there, sign up for our regular free newsletter to get valuable discounts on consulting and training services, and a regular newsletter that includes a featured article on software testing and quality and news about what RBCS and its partners are doing lately. You can follow us on Twitter at RBCS, on Facebook at Testing Improved by RBCS, on LinkedIn, Rex-Black, and on YouTube, RBCS INC. Current and previous recorded webinars are posted regularly, so watch for them on our social media. We offer these free resources as a service to the software testing community because at RBCS we are a not just for profit company. But don't forget, we also need to keep the lights on, so please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. That concludes the webinar. Thanks for joining us today. See you next month.